Good afternoon guys, and welcome to another worked exam answer video. In this video I am having a look at a GCSE structure and bonding question where this question has come from an AQA paper, but again this is something that is pretty universal across the GCSE specifications. If you're not sure whether this is something that you would need to be aware of, you could have a look at your exam board's specification, or please feel free to ask and I will do that for you. Within this question, we're having a look at graphite and diamond. And graphite and diamond are different forms of the element carbon. So that means that they are purely made up of only carbon, but based on how those carbon atoms are joined together, the graphite and the diamond have very different properties, and we're having to explain some of these properties in this question. Now, it might be that they break down the different properties like this into two different questions, or it might be that you have more of a 6-mark answer where you have to compare multiple properties in kind of all the same part of the question. Either way, it doesn't really matter how they present it. We obviously just need to be aware of what the different properties are and why they exist. So before we get on to actually answering the questions, I thought it would be a good idea maybe just to have a look at the structures of the graphite and the diamond that they've given us in these little images, and have a think about what we can learn just from looking at these. So the black atoms or the black circles, represent the carbon atoms. And because their structure's made up of only carbon, and carbon is a non-metal, the bonds between the black circles will be covalent bonds. Now, what we can hopefully see, and of course in this structure of diamond here, this is not the whole picture, this is like a very zoomed in segment of the giant structure that is diamond. But we can see that some of the carbons, it's a bit more obvious than others, they are bonded to 4 other carbons. So we can see that with that one there, we can see it with that one there, and that one there, and that one there. And it will be for all of them. They've just tried to give us a structure that we can actually see a little bit of what's going on. So we've got carbon atoms, and those carbon atoms are bonded to 4 others. So each carbon forms 4 covalent bonds with other carbons. Now, the graphite diagram is a bit harder to see because they've needed to give us, I guess, more atoms and bonds so that we can see these distinctive layers that we have within the graphite structure. And that's going to be really important for explaining some of the different properties. Now, where do those layers originate from? Well, again, if we can have a look at, say, that carbon there, or that one there, or that one there, or that one there. And we look really closely, which I appreciate is going to be quite hard for you guys to do on the video. But those carbons are only bonded to 3 others. And that is why, even though both of these structures are made of carbon, they do have very different properties, because each carbon only forms 3 covalent bonds with other carbons in graphite, but we have 4 bonds from each carbon in diamond. And that should be sufficient for us to then be able to go on and explain the 2 things that they've asked us to talk about. So it says that graphite is softer than diamond. Explain why. And then we've got graphite conducts electricity, but diamond does not. Explain why. And both of these come from what we've already talked about. the layers, the different number of covalent bonds between the carbon atoms within the structures. That's true for both of these answers. So we now need to think about what the key specific parts of our answer are going to be. So the first thing is to essentially write what I've put on the diagram in the first part of this answer. So in graphite, each carbon atom is only covalently bonded to 3 other carbon atoms, whereas in diamond each carbon atom is bonded to 4 others. That then affects what we can see in terms of the shape. So this means that graphite exists with layers, whilst diamond has a tetrahedral structure. And that word tetrahedral is a word for the shape that we get around each carbon when that carbon is bonded to 4 things. So we can't say that for graphite because graphite doesn't have 4 bonds from each of its carbons. So that's the next thing. Diamond is actually the hardest substance that we know to exist, which is pretty cool. And if we've got all of these covalent bonds between all of these carbon atoms, and the structure is made up of millions and millions and millions of carbon atoms, and thus millions and millions and millions of covalent bonds, that's going to take a hell of a lot of energy to break down. Whereas with graphite, yes, we do still have lots and lots and millions of carbon atoms. We have slightly fewer millions of covalent bonds, but that's not what we need to do when we think about using our pencils, which contain graphite. We can put very little pressure of our pencil onto the paper, but we still get a line appearing that we can see. Yes, it might be very faint, and yes, we can press harder and get a darker line, but we can get the graphite layers to flake off really quite easily with not a lot of sort of effort at all. You could definitely not do that with diamond, and that's because the layers in the graphite are held together by really weak forces, which we can overcome ourselves by just popping the pencil on the paper and drawing a line. That's not going to happen in diamond because there are no such layers with weak forces between them. It's just all very, 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 very strong covalent bonds. So that's what we need to finish up our answer with now. So the layers in graphite are held together by weak forces. And there might be a bit of a thought of using the word intermolecular here. Please don't, because the layers are not molecules. Intermolecular means between the molecules. So yes, there are weak forces between the layers, but they're not intermolecular because the layers, doesn't work like that. So you can just say weak forces. It's one time we can be slightly more vague. So the layers in graphite are held together by weak forces. So little energy is needed to separate them. whereas the many strong covalent bonds in diamond take substantially more energy to break. And there we go. That would be what I would be getting down for that question. So graphite is softer because we have fewer covalent bonds from each carbon atom. Therefore, you get the layers in graphite that you don't get with diamond. The layers in the graphite can easily be kind of pulled apart because there's only weak forces between the layers. Whereas in diamond, if we wanted to break any part of the diamond structure, we'd have to break many strong covalent bonds. And breaking bonds takes a lot of energy because all types of bond are very, very strong. Okay, so hopefully that makes sense. Same sort of idea when we're then thinking about part B. So graphite conducts electricity, but diamond does not. Explain why. The first point is exactly the same as what we wrote for the first point here. The ability for graphite to conduct electricity comes from the fact that each carbon atom is only covalently bonded to 3 others, whereas in diamond, each carbon atom is bonded to 4 others. So we can say the exact same first point. So you don't have to watch me write that out again. I'm just going to put point 1 from the above answer. Now, if the carbon atoms in graphite are only using 3 of their 4 outer electrons to bond to other carbons, there is going to be 1 spare electron per carbon atom, which can then form a sea of delocalized electrons, i.e. the electron on each carbon won't stay stuck on that carbon. They kind of all have this ability to move throughout the layers of the graphite. And when we have charged particles that are free to move, that's how electricity is conducted. And because diamond has all 4 of the carbon, each carbon's electrons being used in bonds, the carbon atoms don't have a spare electron. There are no delocalized electrons in diamond. There are no charged particles free to move. So no conduction of electricity. So let's get that down. So this means each carbon atom in graphite has 1 electron that is not used in forming a covalent bonder, and all of these electrons form a sea of delocalized electrons which can move through the layers. This is why graphite conducts electricity. So then we just need to say why diamond does not. So finally, in diamond, each carbon atom uses all of its outer electrons in forming covalent bonds therefore there are no charged particles which are free to move, hence diamond does not conduct electricity. So, in terms of the key parts for our conduction of electricity, graphite, it's the sea of delocalized electrons which can move through the layers. We've then got, or we can just say the delocalized electrons which can move through the layers. And it's the movement of those delocalized electrons which is really important. Diamond, there are no delocalized electrons or any other charged particles which are free to move, and that means that we can't have conduction of electricity within the diamond. Where those delocalized electrons in the graphite comes from is the fact that every carbon is only forming 3 bonds, and thus we get these layers, which brings us back to the first question where we need to recognise the different number of bonds that each carbon atom is making in the two structures. The fact that then the graphite has the layers and that the layers are held by weak forces, whereas diamond, you'd have to be breaking some of those very strong covalent bonds, and there's a very different amount of energy needed to do those two things. Hopefully the way I've approached that means that you can see how I could use the diagram to help me to think about how to answer this. Yes, we do need to rote learn some of the key phrases that we need to give in answers like this, but if there's diagrams provided, make sure you have a look at them and see what they can tell you, because even if you hadn't have remembered about graphite being in layers, you can see it from the diagram. So always make sure you're having a look at those and not just thinking, okay, yeah, they look vaguely familiar, move on, what do I need to say? Have a look at them. You don't have to annotate it like I did, but certainly have a look at them would be my advice. Any questions, guys? As always, please do not hesitate to ask, and yeah, I look forward to doing another video for you soon. Take care, everyone.